Hello, today we want to look at a few standard form of a line applications. I've got two examples for you. Let's get started. A marching band is trying to sell 200 pounds of fruit in order to raise money. The fruit is sold in two increments, 5-pound bags and 10-pound bags. I want to write an equation to find the number of each type of bag the band should sell. I want to graph that equation, and then I want to use that graph to name several combinations and types of bags. Let's take this in small chunks. First, I recognize I have two different types of variables here, a 5-pound bag and a 10-pound bag. So let's let F represent the number of 5-pound bags and T represent the number of 10-pound bags. I could just as easily use X and Y, or any variable. I also recognize that I want to sell 200 pounds of fruit, so my total needs to be 200 pounds. Well, each F weighs 5 pounds, and each T weighs 10 pounds, and of course total means I want to add those together. So my total weight is going to be 5F plus 10T equals 200. Now I have an equation. Great. Now that I have an equation, let's do the second part, and let's graph that equation. Because this is in standard form, I want to use the x and the y intercepts to help me graph. A reminder, to find the x and y intercept, or actually in this case it's the f and the t intercepts, I want to plug in 0 for the other coordinate. So to find the f intercept, I'll plug in t equals 0. That gives me 5F equals 200, which of course means that F must be 40. Whenever T is 0, when I have 0 10-pound bags, I must have 40 5-pound bags. On the other side of that, I can plug in F equals 0 to find the number of 10-pound bags I need when the 5-pound bags are 0. You can see here that 10T will equal 200 and T must equal 20. It will take me 20 10-pound bags when I have 0 5-pound bags. Using the intercepts to graph gives me a nice line. So I've written an equation to represent the situation. I've graphed that equation. Now let's use that graph to name several combinations that work. I already know if I have 0 5-pound bags, I need 20 10-pound bags. And I know that if I have 0 10-pound bags, I need 40 5-pound bags. But what other combinations work? Let's look throughout the graph and find some nice easy ones. Here, I can see that if I have 4 5-pound bags, I would have 18 20-pound bags. Another nice point, if I have 8 5-pound bags, I would have 16 10-pound bags. If I find all of those points, you can see that there are many combinations that give me 200. It is nice to notice here that in reality this is a dotted line. This is discrete. Since I won't be buying half of any of these, I must buy complete bags. Let's try that again with another example. The Student Council is sponsoring a carnival to raise money. Tickets cost $5 for adults and $3 for children. They would like to raise at least $450. Let's discover our variables. First, we recognize that it costs $5 for adults, so 5A could represent our variable, and $3 for children, so 3C. And we need a total of at least $450. Now that's an inequality of greater than or equal to $450. So the total for adults and children must be at least $450. Now let's use our intercepts to find where this graph would cross. Again, to find the C intercept, I can plug in A equals 0. And I find that the C intercept happens at 150. When I have 0 adult tickets, I must sell 150 children's tickets. The A-intercept is going to be when I plug in 0 for C. And I get A equals 90. When I have 0 children's tickets, I must sell 90 adult tickets. Looking at that graph, and then looking carefully for some key points, I can identify that 30 adult tickets and 100 children tickets, or 60 adult tickets and 50 children's tickets. Thanks for watching. Be sure to like and comment below.